Welcome back, everyone. And today is going to be the start of a new thing. As you see on the screen, I have a GDC conference video up. And in the last video, we calculated the weight for our armature bones. And the whole idea is because I want to start doing armature animations and do forward kinematics and inverse kinematics. I want to do a lot of these things. And it's really kind of the driving force is this video. And the idea is that Ubisoft created a system called IK rigs that allows you to have pieces of animations that you can mix and match, and you can configure, and you can easily add new pieces to it, and you can animate each aspect of the body. You know, you can animate the legs a little bit different, one leg different from the other, and you can kind of mix and match the pieces. Like this example here, it's all one animation. It's one original walk animation with small little tweaks here and there. Like the guy mentions the yellow, they just have the chest stick out a little bit more, or the woman, her hips move more, things like that. So, but like I said, it's all a lot of it becomes programmable. You know, they use tools to create some of the animations, or they programmatically make some of the animations. But they're able to kind of import it into their system where they can mix and match and just really use it for anything. So they can have one set of animations that works with any rig or any model they have at all. And they do more than just human. They do quadrupeds and a bunch of other animations. They do some really cool examples of like how versatile it is. Like this one walk animation works on all these different types of leg. This one's more of an octopus leg. This one's kind of like a piston, but it's all the exact same animation. So I'm going to actually attempt to recreate IK rigs. It's a very ambitious endeavor, but since I want to make games and I'm going to be the only person making my own game, it'd be great to have a system that I can programmatically create animations for. So if I create one set of animations, I can have all my characters do it, and I think it would actually make modding super easy, because that's going to be one of the most important thing in my game is mod. I want to be able to mod things. So having the ability to easily programmatically create new animations, and not without a tool, just sit there and like the way I want to do it. Like I want to do it in multiple ways, but the first part of the way I want to do it is just assign a bunch of angles and things, and just let it go. Just a little bit of timing, a little bit of angles and animations. So in this video, we're going to focus on building a walk animation, a walk cycle. And we're going to completely with mathematics. And I really have to say thank you to Coding Math, because he has 4 videos about kinematics, just basic kinematics, just the ideas and some of the mathematics, but everything is done in 2D. But if you sit there and watch it a few times and then really sit and think about it, it's not that hard to apply it into 3D. Instead of using angles, you're using quaternions, and quaternions are a little bit difficult to master. They're hard to have an intuition of how to use it. I've made a lot of mistakes trying to build my some of my procedural animations, and even my inverse kinematics. I wasted an hour because I had things in the wrong order. You know, A times B should have been B times A. So it's things like that. But overall, we're going to, I really want to say thank you to him, because once I saw this video, and I saw this like probably a year ago, he did a perfect walk cycle. And this becomes the starting point of my version of IK rigs. Building animations this way, just with angles and timing. And you can do some really good and I'll show you some things I did. Like I said, he did this in 3D, and all he did had is just 2 legs working. All right, so but I will have the links to these 2 videos, and one more other video as well, another GDC that I also take inspiration from, about procedural animations and how to programmatically create new animations and really do some really good stuff with it. And like I said, this is where I'm going to go with for moving forward, because if I want, like, once I have the system all set up, climbing will be so much easier. Maybe I can do some really cool fighting things, especially since everything is inverse kinematic. I can add inverse kinematics to it. I can react more programmatically to the environment. So things aren't scripted. Things can just automatically change just because the other things around the environment change. So I'm really excited about this. I don't know if I can convey how excited I am trying to accomplish this. Like I said, it's very ambitious for someone like me who's never been to college, who's self-taught and doing this by myself. But I'm this is gonna be fun. This is gonna be a fun journey. I hope you guys are gonna enjoy watching and really get to learn with me. And I'm kind of hoping this to be, in the end, like a very useful open source project. Like if I managed to actually build a decent IK rig system and have all the animations programmable, like they can easily be programmed, like just with angles and just maybe other little things, maybe little tools that kind of convert animations into this format that I want to create. Maybe I can build a library of animations that people can contribute to, and it kind of becomes this very universal. Everyone can use it. It can be ported into Unity, can port it to any system you want. Where like Ubisoft kind of like has it for only themselves, and everyone has to kind of build their own little thing. So this might be my open source version where maybe everyone can use it, because I went to search for something like this and I can't find it. So it'd be fun to this to me is one open source project I can really sink my teeth into, because I love this. This is one of the, I think, cornerstones of graphics programming. Just be able to create animations with math, and I love the idea of it. I like the idea of effects, but this has inspired me so greatly that this is where my main focus is going to be for a long while, to try to build this system. So enough talking about this BS. Let's really get to the nitty gritty. So let's do a plan of attack. So I highly suggest you watch all of Coding Math's kinematics videos, because it's very educational. But I'm going to give you the bare essentials of what we're trying to accomplish. We're going to accomplish this a walk cycle. And the basic idea is that we're going to have 2 bones, right? We have only 2 bones. This is the thigh and this is the calf, right? So everything we've built so far has been joints. So we're going to build a rig system where we have a joint and we have a length. So that's the point of rotation. That's what a joint is. And then the length kind of determines how long that bone is. And we did that in the previous video, determining the length, because this way we can then properly map vertices to bones and then add some weight to it programmatically. So like I said, the previous video was kind of like the precursor to this. That's why I wanted to start really building up the joint and bone system and then really get things going. So we're going to have 2 bones that we're going to animate. And the simple walk cycle is, like I said, we only need 2 angles, really. So we want the entire leg, or really, we really want to focus mostly, the entire leg will go because of parent hierarchy, but we want this bone to animate in a circular motion this way. And we want it to go about 45 degrees. Negative. So this is going to go straight and go 45, 45, right? That's how a hip moves. That's how that bone, that part of the body works inside a walk cycle. Now we got our calf. Well, I forget what I call this. I forget what bone part this is called. Shin. The shin. That's called the shin for me. For everyone else, this shin can't rotate this way. It can't go that way because you have a knee. The knee stops right there. So that's basically 0. So we want it to rotate in this direction, which is 90 degrees. So we can rotate this 90 degrees, between 0 and 90 degrees. I think another approach Coding Math does is to keep everything uniformed. He automatically moves this leg here, so it's at 45 degrees. Then from this point, you rotate 45 and minus 45. So this way, minus 45 gets you back to 0, plus 45 gets you back to 90. So you can go either approach. I think I started off at the middle. Then I think at some point I decided to change it where I want to keep the bone at where it is and just rotate 90 degrees. So it's up to you. It's a personal preference. You just got to fix your timing. That's about it. And you move these at basically at different times. And I'll probably explain how we're gonna do this. And we're going to when you're traveling through animation, we're going to just count basically seconds. But Coding Math does it in a certain way, and he never explained it why he did it the way he did it. But after sitting down and really working with it, I kind of got a eureka moment. The way he works it is, it just takes a number and does an increment and just keeps adding on. But sometimes he creates these offsets, and he uses angles to create offsets. So like let's say we start at the zero, and we're animating to infinity. So the right leg is moving. So the right leg is doing its animation. The left leg is the exact same animation, but it's timed differently. So what he does is he does 0 to infinity plus, don't want that, 180. And that's because ideally, because he's using a sine wave. So when you add a sine wave, you can add radians, and that gives you a value between -1 to 1. So he's essentially using angles to kind of give you a very simple offset where when one leg is at 1, the other leg's at -1. So like I said, he didn't really explain it, so I really want to make sure you guys understand that, because now I'm taking this idea where animation is a circle, and like I said, it's timing, so it makes perfect sense to use angles. So if we're going to consider our animation as a cycle, kind of like one of those first animated things where you kind of have a circle, the metal circle that spins, and you have a horse running. I don't know if you've ever seen that. It's something like that. So where this is the first frame, and then at the end of the cycle, you're back at the beginning, and then you start the animation again. So we're going to be kind of basically taking that idea of where we're going to just cycle animation, and once we reach the end, we repeat. And this will be basically be 0, and it will be 360 degrees. So we can use this as a timing mechanism to offset our value. So this way we can say, one leg starts here, the other leg starts here, but maybe the shin actually starts here in the circle. So when everything cycles through this like time, everyone's off by this certain amount. So this is the first leg, and then this is the second leg, and they're all perfectly timed in the circle, and they just keep going nonstop to infinity until I guess you run out of memory, and you break the integer value, or the float value. So that is the concept that we're going to do. We're going to animate the legs. I think in Coding Math he calls it phase, and it kind of makes no sense. Like if you go watch another video, it's by Coding Rainbow. He also does kinematic videos inspired by Coding Math, but he doesn't like to use phase either. I think he uses phase, or he does use a different word. I'm actually going to use a different word as well. I'm not going to use phase. It makes no sense. I'm actually going to call it a cycle, because when I draw it out on a piece of paper, this is the concept of the animation, how the animation is going to work. It's going to be a cycle. I start here for the left thigh. I'm going to cycle through that animation, and when I get back to 0, I'm going to start all over again. Because like I said, I'm just rotating back and forth between 45 and -45, and I'm using the sine wave to help me get there. I can use a triangle wave, or any wave you want to kind of create, but the sine wave actually does a nice smooth motion. It looks more natural. Like Coding Master, that's what he uses sine wave because it makes it more natural looking, and it does. I tried other different things, and the sine wave does a really good job of it. You can use anything. You can use a Bezier curve, and you can customize your curve so maybe it's a sine wave but a little bit different. Like I said, it's up to you. Whatever you can. The idea of the animation system I'm going to do is you can actually choose any curve you want in the end. So you can use sine wave and other things, tweening functions and whatever. So the animation, I'm going to call it like the timing. I'm going to call it the cycle. So you'll see it in code. It's called cycles. How many cycles do you go through? An idea, and the whole thought is, one whole like animated piece goes through one whole cycle, or a fraction of a cycle. Because I think I do some animations. All right, so let's look at some code. All right, so we're gonna start off with basic stuff. I think this might be new, armature preview fong, so I can actually do some cool armatures. I have like new bones. I add like meshes that I added. So it's not just sticks. I can do diamonds, and I could do diamond wire. I can do this weird circle thing. I don't know if I showed it in the previous video. Maybe I did. So I'm going to start off with a lot of the same kind of code before how we built armatures. And here I have something called human rig, and I initialize it. And then I pass in, and if you know all my ECS in functions, they always return back the entity that you pass in. So I pass in an entity, it initializes the armature component and data, and then the human rig takes in the armature entity and adds the human rig component, and then does other things to it as well. Wow, I'm really having a lot of problems with my throat lately, so bear with me. All right, so human rig, everything else, everything's coming out. We're gonna see all this stuff later. Sorry. That's gonna be our walk cycle test. So here's our human rig. Oh my god, my throat is like super dry. I can't get it undry. So I have a human rig component, and the human rig component, I'm actually taking things into arrays. Oh my god! So, and this is kind of based off the Ubisoft, because they say they do things in chains. So I'm doing the same idea, chains, and it makes animating so much easier. So this way, any skeletal system you bring in, I can just automatically say, okay, those three joints is that leg. Those three joints are the right leg. That's a spine. That's a leg. So this way, I can kind of keep all my animations kind of universal, as long as everything kind of conforms eventually to these chains. Later on, I want to make these chains a little bit more dynamic, so they're not just stuck at 3 and 4. That maybe they could expand a little bit. And in Blender, I set up a Rigify armature, and I just went and looked at all the pieces and got the name. So this way, I'm trying to use something more universal. Like in the end, I might end up making my models in Blender, so I might use Rigify. So this way I have like standard names. So this way I'm actually kind of creating my own rig dynamically. And this is the same way we did in previous videos. So we just add joints and we say what parent it is. But now I'm actually building the entire rig. And I have one option here, just say just legs, because in the beginning we're just going to play with legs. And then in the end of the video I'll show you full body animations with the rig. Oh my god, this is going to be really bad. I'm so sorry. I've been like this for a couple of days. Alright, so that's our rig system. Very simple. Like I said, it just a couple of chains that defines the main pieces of the body that we want to animate. And this is just defines all the actual bones. If this is coming from, this might be actually one of like, the way Ubisoft does it, they have their kind of like built-in rig, and then every other system kind of somewhat conforms to it. So it's going to be a similar idea. I want to be as flexible as possible, though. Oh my god, this sucks. All right, So we're going to do our walk cycle. So we're going to animate the left leg. And the first element is the thigh. First 0 is the thigh, 1 is the shin, and 2 is the foot. So we're going to use start time and speed. And the speed is just how fast we're going and then passing it. So this is a constant time moving forward. We're using since start for fungi as a constant time moving forward. And by using that, we kind of get like an angle value between -1 and 1. So we're going to use pi quarter, which is 45 degrees. And we just say, let's say 1 times pi, quarter pi, or whatever angle we're currently in based on this time. Give me that current angle. And I'm going to use the x-axis. And I'm just going to rotate on the x-axis by 45 degrees. So I create a contorian that is that rotates at that axis at that angle. And and I think I also added to the system something called bind rotation and bind position, because I need to know the initial state during the bind pose. So the whole bind pose process has been changed a little bit just to add the initial value. So this way I can use it as a starting point when I want to move bones in the right place. So this is basically the initial value, the binding pose. This is where I laid out the bones in the Rigify, basically. Its default rotation is default rotation, default position. So this is the out value. So I'm going to save the value into that bone's rotation. So I'm going to take the starting rotation and multiply it by this rotation. With contorians, I'm actually kind of like 3 videos ahead. So like I said, I'm already up to doing inverse kinematics. I have problems with contorians because sometimes some places say when you want to combine contorians, like essentially kind of add them up, you have to multiply them. And the order sometimes is funky. Sometimes they say it's old rotation times apply rotation. The rotation I want to apply to it. Like I want to rotate this by that. And other sites I've seen that says you have to do the other way, where it's the applying rotation times the old rotation, the current rotation. So I've come to realize that if rotation acts a little funky, swap it. Even though it doesn't make sense. So, like I said, I'm having a hard time getting a good intuition when it comes to contorians, but at least I have some tips where, like I said, if one doesn't work, just try flipping it. That might be your problem with contorians. But in this case, this works just fine. Initial rotation times applied rotation. I'm trying to apply a different rotation to it. It's not the new rotation. The new rotation is this plus this, basically. And that saves it to the new rotation. So ideally, this should make this. See, here's my my rig, and there you go. I got my leg rotating by 45 degrees. And actually, that's kind of annoying. I can actually fix that really, really quickly. If I go to fungi, actually, no, it's not in fungi. It's actually in fungi mods, modulars, and shaders, and all I gotta do is test the true. Sorry, because that's really distracting. With seeing the back leg kind of phase in front. There you go, much better. Or not. Did I fix it at all? Empty cache. There you go, much better. All right, that's fixed. So, there we go. We got that first leg animating. So like I said, we're rotating it by the x-axis. As you can see, the red line is the x-axis, so it makes it easier to tell. and we're just rotating it. We're just rotating that bone, and it moves the rest of the leg with it. And now we rotate the shin. And with the shin, we're going to do it a little bit behind. And we're going to rotate, like this might be like between 45 and 45. Yeah. So I'm basically doing the 45-degree angle and then rotating between negative 45 and positive 45. That was like the second solution. This is more how coding math does it. Like I said, I know some later versions I do for between 0 and 90 instead of like 45 and then going back and forth. But essentially it's the same idea. I'm rotating between negative 45 in both legs. The only difference is I'm doing this at a different time. Let me do it without this time. So I'm actually doing it behind a little bit in the cycle. So remember that example I showed, the circle where the leg starts here, and then I want the shin to be at a different point in that cycle. That's what I'm doing. So if this is the current cycle time, just by adding that negative, I'm shifting it to a different time that I want it to be at. So this is what it looks like with. Did I save it? Yeah. Empty. So this is the rotation. So they're timed perfectly together. They're both rotating between negative 45 and 45 at the same time. This one actually looks like he's kicking. So right off the bat, we have an animation for kicking the can. We got a kicking the can animation going. So he's like, boom, he's kicking a football. So there we go. So one animation done. We have a kicking animation. So if we do 45 and synced together, we have a kicking animation. Now if we want to, like I said, if we want to make it look more like it's walking, we just change the timing of the shin. So we make the shin rotate, I guess, sooner, or starts rotating at a different time. And just by changing the timing, there you go. Now it rotates. Like it rotates just right where it rotates forward when it's time to kick. So now he's like kicking the floor. So just, like I said, just changing the timing works. So like coding math has the right idea. And that's really much animation. It's kind of like when you're using like a keyframe editor and you just move the keyframes around. That's all we're basically doing. We're just moving the keyframes around. We're just doing it with code, with the idea of math. If you want to think about this like this time function, you can think of it as the keyframe timeline. You're just moving the keyframes around. So I just moved the keyframes for this animation behind it for that leg. So this animation happens sooner. This happens. The top leg happens later, and this one happens sooner. And the other leg. It's the exact same animation, exact same code. The only difference is we're adding pi. Like I said, it's a cycle, it's a circle. So if you want to make something, if we want to do the exact same animation, but just time it at the opposite time of the cycle, you just add pi to it, which is 180 degrees. So it's the exact same code as the leg with pi added to it, to the mix. And with that in mind, there we go. We have procedurally generated basically a walk cycle in 3D. It's all with quaternions instead of using angles. The end. But there you go. We got it working. It's great. It's beautiful. I love it. This is awesome. Once I got this working for the first time, I was doing the dance of joy. Wait till like 4 videos from now. I'm actually going to be able to walk. Actually, the armature will actually walk in future videos. I got to work that. I was really like just jumping for joy. I was like, I got it working. Yes, beautiful. And the way I got it to work is not. It's basically based on the foot, like real physics of the foot. Like the foot touches the floor, it pushes you forward. That's going to be like 2 or 3 videos from now. But yeah, that's it. That's that. Like I said, this is the starting point of a procedural animation. It's just rotating things in a circular way, essentially, especially if it is kind of like a repeated pattern. If it's not a repeated pattern, then it's basically a 0 to 1 animation, and you have a starting point, you have an ending point, and then you kind of lerp between the two. Because this is essentially what we're doing. We're doing a lerping, without the lerping function. We're just calculating because you can look at time as the t value. Like I said, it's a cycle, it's a timeline, it's all that. Now that we got basically the walk side or prototype working, and we can actually change the speed. So if I want this guy to go like run really fast, I can change this up to 5. And now he's kind of like it feels like more natural, like it's a jogging animation. It's more of a jogging type of thing. And like I said, the animation is the same. Like I said, like Breath of the Wild, they have that slow motion thing, so you can so you can very easily just adding some quick timing. Now you're in slow mo, like, and all the animations are the same. That nothing has changed. Now the only thing is I'm changing is basically essentially that incrementing of time. It's like, how fast am I going? So now you got this slow motion thing. You got bullet time going on. You imagine in your game you can have every single character in the world go in slow motion, and you're going at regular speed. That might be a fun little mechanic to play with, like the Flash. The Flash has flash time. Can you imagine playing a game in flash time? That might be fun as hell. Like there might be games out there that exist. I don't know, but like I said, this is fun. This is really great stuff. I love it. Now it's back at regular speed. You're no longer in flash time. So that's the prototype. So once I got the prototype working, like I said, has to be a system. I want to be like the iCake system. So, and I want it to be able to kind of build things in pieces. So I got proto animation update, which takes the same idea of the prototype to the same level. So let's see. Load function, basically I pass in like a JSON string and with information, and it kind of loads up all which bones, which angles, and what timing values you are. Like basically that prototype built as a class. All right. So, and the items are just the items that I want to animate. And this is the update function. I have and this is like I said, an ECS type of system. So you build it once. So like I said, I have a cycle. Instead of using trying to think, instead of using since time, I don't want to use that. I want to control the actual time completely. So I got rid of that. I am using delta time because I want my animations to be it's like the animations are going to be done per second. So how much per second? So this way it becomes frame rate independent. So if for some reason your frame rate drops a little bit, the animations will continue. They will be where they're supposed to be, even though you lost some frames. So if it's a type 0, I'm doing a rotation, and if it's a type 1, I'm doing a position. So I'm adding position to it because one of the animations I created, I needed to change the position, not just rotation. And like I said, it's very simple. And you have curves. So you in the code you pass in what curves you want. Let's see. And I'll show you the curves. And the curves are, like I said, I have a sine wave. I have a sine wave, but returns back a 0, 1. I have a sine wave that returns an absolute value. So the idea is that you can, for every animation, you can choose a different curve, which allows you to overall change how it moves. Because sometimes maybe different curves will make the actual animation work. So that's going to be one of the trickiest part of doing procedural animation, especially code-wise, is that maybe to get the certain motion right, you need to get a certain curve. And down the line, I'm probably going to do a Bezier curve so you can pass information. And you have that distinct curve to help get the animation working just fine. like a spring. I want like maybe a simple springy curve will help to do certain animations. So this way, something doesn't just stop where it is. It kind of just bounces a little bit. It has a little spring to it, a little like ease to it. And the other main part of this object, like I said, this is not that big of an object. I have a load that loads in JSON. I have an update function, which is not that big. And then this is basically how you add the pieces. So if I want to add a piece of animation, I say, what joint is it? A reference to the joint. What's the speed of the animation? What's the starting value? What's the ending value? Where is it in the cycle? So it could be 0, it could be like everything in, like, say you use radians to kind of add things to the cycle. And what curve I want to use. It's just the text reference to it, because then I can access it easily through here. Like I did up here in updates. So, so it's kind of like a function pointer. And like I said, I made it really easy. I can just add more curves to it and then use the name of it, and it's a function pointer. So like this little object, it can animate. Can be used to animate pretty decently. And like I have two functions: add position and add rotation. So I can do. You can do two. You can apply as many single bits of animation at a time. So if you want to do 2 rotations for one joint, you can't just add 2 rotations. Just put them into proper order. Actually, can I? I'm not sure. Actually, no. I think in the future I probably will be able to. But right now, I guess there's 1 rotation or 1 position. You can do both at the same time, though. So, and I built the rotation because I want to make the code, the JSON as small as possible. So I want to do 2 different formats. I want to be able to pass an array of 2 elements and say X and then 45 degrees. And I'm going to use degrees instead of radians, so it's more user friendly when I'm rating it. And it converts everything to radians for me. So like I said, the format is gonna be like I said. I want to create like this very simple format that's that's human readable, that user can sit there and modify manually, and just create animations that way. That'd be really awesome. And especially if you can mix and match, and like the walking animation for a leg is the same. So for 2 legs, so you need just 1 animation. All you got to do is change the timing, and you can do the same thing for arms. So basically, for a full walking animation, like not a great one, but a decent one, it's just 2 animations. Just one for the arm, 1 for the leg. Maybe add something to the spine so that maybe there's a little contraction, a little bounce. In my animation, I think I added a shoulder movement on top of that. So I added to the chest bone. So I rotate the chest bone. You'll see it in a little bit. But yeah. So here we go. So yeah, that's and I calculate the angle, the quaternion that I need to use. And yeah, that's it. And I'm bouncing back and forth. I don't know why. I'm excited. I don't even have coffee yet. That's right. And during the update, like I just use a lerp function. So I take the starting point, the end point, have time. I save it to a quaternion, and then I do that multiplication I did in the prototype. So I lerp. I can do slurp as well. But since I'm using sine wave to create time, I can use lerp as well. Well, when it comes to rotations. So and I think lerp is less code intensive than slurp by a lot. And yeah, and add positions is very simple. There's nothing to it really. And like I said, I wanted 2 formats. I wanted a simple format, but if I want a very specific access, I can define the full access, and then the 4th component will be the angle. It's kind of like a quaternion. That's what a quaternion is. Essentially formatted like this, except this would be in radians, but it's like the cosine of a radian. I don't know. If you look at how this function creates, you'll see how it generates that quaternion. It's kind of interesting. But I don't understand quaternions very well. Like I said, I keep saying I'm trying to build an intuition for it. And this system is going to really teach me how to use quaternions, because I have no choice. Because I built fungi to use quaternions. I have to learn how to use quaternions to build this system. I'm sorry. Oh my god, this must be horrible for the audio. I need a bigger cup of water. All right, so yeah, and that's the code. Yeah, everything's on GitHub, and so yeah, I can build things this way, like Pro Animation, and just build it like programmatically as a prototyping, or this is what I kind of wanted to do is more of a format, and here's a walk animation. And this is the walk animation. Again. Oh, well, this is the walk animation I created. It's very like I shrink down the angles, so so as you can see, for the thigh, I start between 0 and 25 instead of so like I said before, the proto example I do between -5 to positive 45. Here I'm just doing between 0 and 25, and then I'm using the sine wave of 0 to 1 to animate that. So like I said, you can create the exact same animations by using slightly different curves and by using different angles. So, but you can accomplish the exact same thing. But it's a lot easier to start off with 0 and then move the angle directly and just change the cycle offset. And the speed's right here. And like I said, these are all quaternions. I think this is a quarter pi or just half pi. Can't remember. Yeah, this is half pi. This is half pi, I believe. Half pi plus 180, which is adding a whole nother pi to it. But that's the speed of that's the angle I want to travel per second. So it's rotation per second. Like I said, I added that frame independent thing. So all the values are a per second type of value. It's not a per frame, it's a per second of frames, worth of frames, depending on how many frames you can push out within a second. Yeah, that's it. And that, like I said, that is the walk cycle. And if you, for funds, I can add the rest of the rig back in, so I can say false. Refresh. And there's our little armature. I know it doesn't look great, but it gets the approach. So there you go. So that's the walk cycle. Now I programmed the jog cycle. So now I got jog, but now I did the whole body because coding math at the end says, I challenge you to add the foot and everything else. And I think I do add the foot. Do I? No. I don't know. I think I did at some point, but refresh. And here's the jog. Like I said, I added this bone right here. I think it's called the chest bone. Add a little twist to it, so this way it looks pretty good. He's jogging. Tried to do something with the head, but didn't work out too well. Like I said, I don't care. I don't know. I probably would curve the spine a little bit to make it look more realistic. But like I said, the animation for the arm is the same, and just change it to 180 degrees for the other arm, and there you go. Now I got the swinging arms, and I got the legs, and everything is all animated just right. And because I love Naruto, and I always find that the way Naruto runs is funny, I created Ninja Walk. Actually, I don't know why I call it Ninja Walk. It should be Ninja Run. So here is all the bits and pieces, spine, hip. And the hip, I do a type 1 because I want the animation to look like he's running. So when you're running like a ninja, you kind of bounce off the floor. So there you go. You get the ninja running going on. But it doesn't look very good because it's going slow. And adding like a bounce, like I added a little rotation to the arms to make it look like it's bouncing, and add the bounce. Did I add anything to the head? I don't think so. Like maybe I should add a little bit more to the head. But like I said, you can sit there and just start tweaking every bone and customizing. But I like the long stretches I did. You sit there and just play with it until everything kind of just seems right. And I believe it looks really good at 4. If I speed it up, or at 5, then it starts to really kind of look like the ninja animation. So let's just go super speed. Naruto is in a hurry. He needs to catch up to Sasuke because Sasuke's about to do something stupid. Again. So there you go. There you go. Procedural animations. I think 5 is a good size. Do 5. There we go. That looks good. 5. And it can kind of hide any of the weird looking things in the legs. I think the 4 might be good, but whatever. I digress. And I'm almost out of water, and it's getting harder to talk. So this is the end, really. This is the end. You can leave, but here you go. This is like I said. I want to build IK rigs, and this is really the starting point. Procedural animation. Try to build a kind of a format for animations. I'm gonna change. I'm gonna do more than one style of animation. Like this is kind of like the build it piece by piece type of approach. Ubisoft has a different approach. They kind of talk about, and I'm gonna see if I can build that approach as well, which is kind of like this. They visualize really cool, but like I said, if I can recreate Ubisoft's kind of way of doing it, where you're not, so you kind of start with it's less data. It's like so basically you animate the entire chain in one go just by using a couple small values, like the start and end position. I think angle, which way is forward, and you kind of use all that information, and you can calculate all the angles automatically based on some of that information. So this way, I only need to animate I just need to apply a certain value or a couple of values for one pose, as opposed to adding values for each joint in the leg or in the entire chain. So this is going to really harden any more water. So I'm just going to end it at that. So it must be allergies. I think my eyes are starting to water up too. So, see you guys in the next video. Like and subscribe. Please, thank you. Whatever. This sucks. I'll see you guys later. See you guys.